In this video, I'll talk about rootkits. A rootkit is a form of malware, and it can apply to the Windows platform or the Unix or Linux platform, including at the smartphone level. So it's a form of malware that is usually delivered through a Trojan virus. A Trojan virus appears to be something useful or benign, like free downloadable software. However, in fact, it actually is used as a vehicle to transport malware. So a rootkit then creates a backdoor. A backdoor allows an intruder to keep elevated access to a system or an application without detection. This can be done in many ways, including by replacing operating system files that allow and hide intruder access. For example, consider a rootkit that replaces the netstat command on the Windows and Linux platforms. The netstat command is usually used by administrators to view any connections that are made to a machine on a given port or outbound connections made to other machines on a given port. By replacing the netstat command, an attacker can hide the fact that they've got some kind of a listener or that they've got some kind of a process that periodically reaches out to receive instructions from some control center owned by a malicious user. Kernel rootkits exploit operating system kernels and their ability to be modular and expandable. Because if we allow access to the operating system kernel, we are allowing access to everything. And in many cases, things like drivers are given operating system kernel ability. So even installing a driver could be a form of malware that could infect a system and install a rootkit. Now, a rootkit could also replace many files. It's not as if it has to replace a single file. So in the case of hiding listening network sockets, as per our netstat example, we have to know what a socket is. A socket is a combination of a protocol plus a host and a port, such as http:// a host name, and then a port number. Other kernel rootkits will actually hide files that aren't seen with normal operating system commands. These files might contain illegal data, or they might contain additional malware payloads. Now, we could also have running processes that are hidden from normal operating system tools like the Windows Task Manager or the Linux PS command. There's also the possibility of kernel rootkits being spawned due to some hidden configuration somewhere, such as in the Windows registry or within a Unix or Linux configuration or .conf file. Now, bear in mind, in order for a kernel rootkit to be installed in the first place, at some level the machine has to be compromised. Countermeasures to rootkits include hardening the network as well as hosts on the network. And of course, running up-to-date anti-malware that might detect a rootkit. There are also specific anti-rootkit tools available from various vendors. Examples include the Malwarebytes anti-rootkit or the McAfee rootkit remover. The use of intrusion detection and prevention systems is also really important in this case to detect suspicious activity such as the replacement of operating system files. In the Windows world, user account control or UAC can also be beneficial in that it can prompt the user of the system before anything happens in the background, such as making a change to the registry to spawn some kind of a rootkit. Also, we might consider disabling in the Unix and Linux platforms loadable kernel modules or LKM. In other words, we want to make sure that what's required for the kernel to function properly, things like IPv6, which may be turned on or off from the kernel, or additional drivers, we want to make sure perhaps that they are compiled into the Linux kernel where possible. In this example, you can see the Malwarebytes anti-rootkit tool that's been installed on this system, where down below the scan targets that it will look at include drivers, sectors on the disk, as well as the entire system. So I'm going to leave them all checked on, and I'm going to go ahead and click the scan button. In this video, we talked about rootkits.